Let's look at the isothermal compression of a gas. I'll take a gas, compress it, and I'd like to know what is the heat flow. Does heat flow into the system? That would be a positive heat. Out of the system, a negative heat, or is there no heat flow? Think about that for a minute and make a selection. Let's look at a possible explanation for each answer. A, delta E is 0 because it's isothermal, and the work has to be negative heat. Delta V is negative, so the work is positive, and that means negative heat. B, isothermal means no heat is transferred, so heat is 0. C, compression requires work, so the system should heat up. Q should be greater than 0. Think about those three explanations and make a selection. We're talking about the isothermal compression of an ideal gas. Now, isothermal is the key word because if the temperature doesn't change for an ideal gas, its energy didn't change. So, no energy change in this system. Now, it was a compression, so work is being done on the system. Delta V will be negative, but we have a negative sign, minus P external delta V, positive work. So, positive work done on the system. Let's look at this. Isothermal, energy change 0. The heat and the work are equal and opposite. The work is done on the system. That's positive work. So that means that the heat must be negative. Now let's think about this practically. I compress the gas. I'm doing work on the gas. I'm giving energy to the gas. And you say, wait, but if I give energy to the gas, its temperature has to change. How can I give it energy without its temperature changing? Well, that energy has to flow out at the same time I give it. So how can that energy flow out? Well, I'll have work done on the system, but every joule of work will flow out as a joule of heat. And we call that negative heat or an exothermic process when heat leaves the system. Practically, it means you probably do this process very slowly. You compress it a little bit, wait for some heat to flow out. You compress a little more, wait for heat to flow out. Or you compress it and wait a while until all the heat flows out. In general, you can do work quickly on a system, but heat flow always takes time. So when you see isothermal, you often think slow because I have to wait for the system to come back to the same temperature or become isothermal. That's an isothermal compression of an ideal gas.